Okay, finally, last question, question 10. So this one focuses on the halogens, group 7. And firstly, we were given some information about the halogens in this table at the top. The name of them, okay, in order that they are in the group. There's the chemical symbols, color, and their state at room temperature. And you've got to fill in the gaps, 4 marks, 1 for each gap. So fluorine, the symbol is just a capital F, nothing else. Okay, bromine, we're given the symbol, but we have to find its color. Okay, and bromine, you should hopefully have seen it as a liquid. It's like a red-brown color, so anything kind of red or brown or maybe even dark orange you could get away with there. Okay, state at room temperature, well, it follows a pattern. If you have a look, you can see that as you go down the group, look what's going on. You've gone from a gas to a liquid to a solid, so you can make predictions even if you can't remember. Okay, this one's going to either be a liquid or a gas, and in actual fact, chlorine is a gas at room temperature, a green, pale green gas. Okay, and then iodine is a solid, so if we follow the pattern in the group, that kind of goes here, that astatine would also be a solid. Okay, right, next question. Question B, another seeing question. What do you see? So think about what you would actually see with your eyes when the shiny black iodine crystals are heated. And then for the second part, what's the name given? So there's 3 marks. You actually see 2 things. Okay, you see a gas produced, or a vapor, okay, and it's actually purple. So that's 2 important things and 2 marks that you can get from what you see. A purple gas or a purple vapor is produced. You don't get a liquid form. So the name given to that change, where you go straight from a solid into a gas, hopefully you can remember, was sublimation. Okay, so that's the 3rd mark. Right, explain fully how you perform a test for chlorine. Okay, now to test for chlorine gas, when you make chlorine gas, if you want to make sure that what you've got is chlorine, is you have to use damp blue litmus. It must be blue. If you use red, it doesn't work. Okay, so damp blue litmus paper. Okay, and what you'll see is what normally happens is first of all it goes red, okay, or pink, and then it will actually bleach. Okay, if it's chlorine, it will bleach. All right, it will actually bleach white. Okay, acids will turn it red, okay, or pink, but if it's specifically chlorine, it's going to bleach and it's going to turn white. Okay, question D, part 1, explain fully. Again, that word fully, so making sure you give lots of detail. Why no change occurs when bromine solution or bromine water is added to a solution of lithium chloride. Well, this is all down to the reactivity in this group. And if you remember, as you descend group 7, they become less reactive. Okay, and if you just remind yourself, okay, up at the top, you can see here that bromine is actually below chlorine, so it's going to be less reactive than chlorine, and therefore it can't displace it from its compound. Okay, it can't take the place of the chlorine. So the first mark is going to be the fact that bromine is less reactive than chlorine. Okay, and then the second part is therefore, so I use those 3 little dots to be therefore, okay, it cannot displace it. Okay, so it cannot displace the chlorine. So no displacement reaction would take place, so you see nothing happening. Question 2, what color change would you see if this time chlorine solution was added to a solution of lithium iodide? So if you remind yourself of their positions by just taking a peek up at the top, what you'll see this time is chlorine is there, iodine is there. So chlorine is above iodine, so it's more reactive than it, and it's going to displace it. And it's also asking you for a word equation for the reaction. This is 2 marks, so we're 1 for the color change and 1 for the word equation. I actually think it's easier if you do it the other way around and write the word equation first, so you can think about what's happening. Okay, so you've got your chlorine, okay, so in solution, and you add it to your lithium iodide. And this time a reaction will take place because the chlorine is more reactive than the iodine. So it's going to displace it. And what you're going to end up with is you're going to end up with this time, you're going to have lithium, I'll write it underneath so I have enough room, lithium chloride. Now notice it changes its name. It's no longer chlorine, it's chloride. Okay, and you're going to get the iodine. So it's gone from iodide when it's combined to iodine. okay, will come in a solution. And if you think back to practical work that you've done, you need to now remember the color of that iodine solution, and that iodine solution is brown. Okay, so the color change that you would see is you would see a brown color appearing. Chlorine solution is clear, so it would change from clear to brown. But as long as you've got some indication of brown or very dark yellow, I suppose, then that would be fine. And that's the end of the test.